Go.
Hello, everyone. Welcome to Practical GCP. So today I would like to spend a bit of time talking about some discovery or exploring I've done with the new offering of the DLP service, which is the Automatic DLP for BigQuery. So I'll start by just have a quick talk about what DLP is and what is actually Automatic DLP. Some Automatic DLP in action. So I've tried it out and to just share my finding of the good and bad. The DLP inspection at table levels, this is something that's going to give you a lot more granular control than Automatic DLP. So I think it's also worth talking about that because you probably end up using this a lot more in reality. And finally, I would like to talk about some options and cost considerations. So the cost consideration in here is extremely important because it's one of those things can cost you quite a lot. Okay, so to start with, just a quick introduction of Cloud DLP. So DLP stands for Data Loss Prevention. It's a service Google offers that gives you, I would say, primarily two things. So first one is around data discovery for sensitive data. So obviously, when you have a lot of data, for example, if you store them in BigQuery, and it is really important that you want to find all those sensitive information and tag them to know exactly where this sensitive data are and then what they are. And then you can actually do other things such as doing the obfuscation or masking, right? So DLP provides both of them. In this session, the focus will be more around the sensitive data discovery, which is, I think, probably I would argue the probably most difficult part in any organization. Automatic DLP. So this is something, a service that Google announced, like I think this back in October 2021. So you can set something up to automatically discover sensitive data in your organization. So what Google claims is you can use this tool to automatically detect sensitive data based on the categories. So it gives you something like this, which is called the data profiles. And then you can create a dashboard. Maybe this is in Data Studio, something like this. And then you can actually find exactly what the distribution of sensitive data is like and where they are and what kind of the type they are. And therefore, you can use this to manage the risk in your organization. This is something I've been looking at for quite a while, but never really had time to try it. And recently, I think this was just a couple of days ago, and the Automatic DLP service of BigQuery now is in GA. So now I thought this is really good time to try out to see what's good, what's bad, and then what it can really do in this scenario. Right. So before I start showing you what I've done, I would like to show you what I've got first. So this is just you have seen this before in my previous videos. So what I've done here is I use some of these previous things I've got from previous videos, but also I've imported some fake PI information. You can see this is some of the names and credit card numbers, cities, zip code, phone number, emails. I've also spent time generating the UK address data, which has address and phone numbers, right? In this particular case, you've got addresses, you've got postcode, and you've got phone number, which is, I just want to give it, slightly different thing. This is more of the US side of things, and then you've got the UK addresses. So I want to just test out with the automatic DLP detection service to see exactly what it can do just out of the box. Right, so this is the data I've got, and the way the automatic DLP service works is when you navigate through in your project, you can go to this section under the security called data loss prevention. In order to use this, you need to set up some kind of scan configurations. So if I just walk you through this very quickly, and then we can see what you can use this for. Currently, I'm at project level. So this automatic DLP service is not something you're limited to do at project level. You can do it at organization level or folder level. So this could be your whole organization from the very top, or your folder level, which could be a department or a function. You can do it all at you can do it like at all of these levels that don't conflict with each other. So what in this case I've done is I've set something up at the project level, so I can just explore a more focused area to see exactly what it comes out with. So after you've chosen, in this case, the project, you have this thing that you can manage the schedules. So within the schedule, if you look at this, so you can start setting your schedule for the profiling. So you can profile the tables, and then what you can do is you can say when the schema changes, right? And then you can reprofile daily or monthly, or just do one-off. And the type of schema changes you can detect are new columns or removed columns. And when the table changes, so this is kind of when the data changes, and then you can also decide if you want to trigger the reprofile, or daily or monthly, right? So these are the kind of options you can do. So once you've done the schedule, this is the most important part here. So the inspection of the automatic DLP. So the inspection is the key part of the DLP or the automatic DLP service. That in the template, so what you kind of using is this thing called info types. So info types is basically a bunch of things that if I just open this up, you can see that you've got all of these different kind of information like tags. You can see that so Google has this kind of built in. They have, I think, around 157 of them in total. So you can use up to 150 in each configuration. So this has all sorts of things such as, you can see there's very obvious ones. You've got age, you've got token, date of birth, right? You've got credit card numbers. There's lots of different things that's built in. If you want to know kind of full list of it, you can go to, these kind of the info type detector reference, which has, the global sections, and you've got the specific one for each country as well. Right. So the things that gets interesting is that you're not actually limited to just use those built-in types. You can also use the custom type. So the custom type in this particular case is, I'll show you kind of some of these ones I've got created for the detection I've done. But one thing you can do is you can use regular expressions. So these things can be quite powerful. So for example, if you look for the built-in type for search for postcode, right? There's actually nothing like postcode in this scenario. But postcode is something that really is UK specific, and it's very easy to detect using regular expression. So in this case, you can actually just add an info type, and then that is customized using a regex. So in this particular case, you can give a name, which is like a postcode, right? And then the likelihood of this section is going to be. So because if you're using regular expressions, you can set it to very likely, because if it detects using regular expression, that's a postcode. It is a postcode, right? So, and then this is the pattern where you put it in. And once you've saved it, and in this particular template, you can use these built-in ones in combination of the custom types in order to detect your things. There are other custom types as well, but in the exploration I've done so far, I've not actually tried these other things yet. Right. So the last kind of the important part of this is the save the data, the profile data into BigQuery. So this will give you ways to kind of analyze your data. I'll show you this later on the ones I've done already. But basically, when you enable it, you just specify your project ID, dataset ID, and table ID, where you want to store your results. Okay, so now I want to show you the one I've done previously, which is the one I set up for doing the detection in this project. If you look at the profile, right, this is the one I've done. You can see that the fake PRI data, the table, and the fake UK address has been flagged up as a high risk. So because these ones are the ones that are specifically created with lots of sensitive data in them. So it seems like the automatic DLP has done a good job in there. So if I look into a bit more into the details on exactly what is done in there, so you can see that in here, it has detected quite a lot of things just out of the box. You've got the US Social Security number, you've got the credit card number, phone number, street address, date of birth, person name, city. This hasn't actually done it, a very good job, but is actually one of the moderate or kind of less important flags. First name is detected as predicted as a first name. You've got email address, and then last name is the person's name. There's also a bunch of other things is kind of missing, and it categorized as low. So I'm not entirely sure, some of these you've got the CVC, credit card CVCs. So I guess it probably doesn't understand what this is, because it's like, out of the box, it's just the integer, right? How does it actually know, what this thing is? So you definitely need a bit more like control or granularity and a kind of detection rules adjustment to kind of give you a bit better detections. But I think out of the box, this is basically, I literally have done nothing, right? I've just selected a bunch of built-in types, and then it just picked up a lot of these things, right? So let's have a look at another one. The fake UK address that I've got in there. So you can see that it has detected the postcode and address as postcode. So this is the custom data type that I've put in using regular expressions, right? So you can see the other info type is also detected is the street address. So it's kind of correct, right? But it's not quite as correct as the postcode one. Because if you remember earlier, what I mentioned is you can actually set this as very likely. So if it's got something that in here that is, almost the exact matches of your postcode, it will give you the better prediction of the exact match. So this one, as you can see, the data risk is high, and you've got the postcode in there that is detected using the regular expressions. Address, again, has detected this as an address. So the phone numbers, it didn't actually do the prediction, but what it has done is there's other info types actually giving you the phone number with this column. So it's done a pretty good job out of the box on, on lots of this stuff. So the rest of them, you can see that these are moderate with some of this data. So we can have a look at what it's got in there on some of these. So you can see, like, here you got latitude, and the latitude is detected as moderate, but it think it's a UK National Health Service number, but it definitely isn't, right? So on this name, I think it's got street address and personal name mixed up together. So it's, you can see it's not actually doing a very good job on this particular one. But these ones, I think, is more complex as well, because latitude and longitude, you can see this one is not even detected as anything. So these are just, just floating point numbers, right? So it's quite difficult for, the DLP service by default to pick things up like this. So these things definitely require a lot more, granular control for you to set something up for it to actually be able to detect this kind of thing. Right. So, but for the most sensitive one, it's actually done a pretty good job in there. So now let me show you some of the export of the data so you can see what it's actually done in there. So this, if I run it again, is looking at the data profile copy, so which is this table. And I've done a bit of unpacking because this is nested data. It's probably quite hard to read if you just look at the table itself. So what I've extracted out is the sensitivity level high and moderate, and I've actually filtered by the fake PRI table. So you can see what you've got in here is the project ID, the DataSite ID, the table ID, the column, and the sensitivity score, the risk level, and most importantly, the info type, right? So it tells you exactly what these things are. So this data is made available after the generation, after the scan of the profiling. Then it then exports every time you run the profiling or the profiling gets updated like a daily or something, then it gets exported into this place. So I guess for the good part of the automatic DLP service, obviously I have very limited time to trying these things out. But I think this profiling results is really, really powerful because you get a lot of insights in here. And then with data like this, what you can do is easily create a such as the Data Studio dashboard to visualize and kind of dig into what is actually happening in your organization. So obviously this is project level, but now you can see you've got, so this is the one I've done a quick pie chart on the distribution of the info types. So you can see the biggest one here is on the street address, right? And then followed by the 21%, which is the name. So you can actually get a pretty good idea of the distribution of different info types and what kind of information or sensitive information your organization is collecting. And then what you can do is to start drilling it down into, in this particular case, which would be table level distribution. You can see the street address is in the fake PI table, and then it's in this project in this data set, right? And you can see there's other ones with the fake UK address, the postcode column is here. And you've got a record count in each of those. So you can see where the emphasis is. And finally, then you can actually use this thing to drill down into very granular details and then filter by all of the columns in here in the Data Studio dashboard to see exactly what info type is on at a column level, right? This kind of gives you a lot of visibility and insight to look at from the very top and then drill down to the very bottom. Then you can dig out exactly what you want to know. Now come down to the things I don't really like so much. So I think, as you can see, a lot of these things, as I mentioned earlier, such as the latitude and longitude, right? So the detection in here hasn't done a good job in my first run. But then, you can't actually, if you go back to the configuration of the data profiles, right? So you can see, because it's done I can choose, right? Repeat daily or monthly, and it can also detect table changes and repeat daily or monthly. But I can't just trigger this whole thing again, right? Because one thing I would expect is I can make a few adjustments in the inspection template, right? I can add a few info types, change a few info types, change a few rules, and then I'll run it again, right? I can then see how it actually improves. But you can't actually do that. In the documentation, one thing it says is you can actually raise a ticket. It's like a support ticket to get a rerun. But that is quite a bit of faff, right? How can you play around to make sure the rule is actually correct? And then, because each organization will have your own data, it generally takes quite a while for you to get the right part of to get the right rules and then the right info types out of it, especially like postcode, latitude, longitude. How would I understand that it just run once, right? So because the detection wasn't perfect, it's got a lot of things that detected as the incorrect data types. So sorry, the incorrect info types. So I need to kind of try these things again, but it didn't really seem to have that option for me to do that. So there's one more thing is about the cost. So based on what the documentation says, the cost is based on, so if you look at those things, right? So the table has a size. So for example, this particular one, it has 24 million rows. But so there doesn't seem to be an option to reduce the scan, for example, to take a sample of the data with the automatic solution, the profiling solution. So the cost, I think, is about $0.03 per gigabyte. But let's say if you have a 10 terabyte table, 100 terabyte table, a new thing, someone copy the data, it can still cost you easily like tens of thousands of pounds, right? So not having the option to sample, the part of that data seems to be a bit of an issue in the detection, because if you actually really have a really large table, you can't actually reduce the amount of data scans. Your only option is to scan the whole table. So I think overall it's done quite a lot of good things out of the box, but I think if it can give me a bit more freedom or a control to reprofile based on the adjustments I make, I think that will be a lot better. That saved me a lot of time. So that kind of leads me into the inspection side of things, because the automatic DLP profiling is based on the inspections. It just does it automatically for you. So for inspections, it typically works on for BigQuery, on a table level. So if I show you what I've done before, So what I can do is I can copy this. So you can see what options you've got in here. So here you've got the job ID, and then you can select the storage type. So in this particular case, I've selected BigQuery. So here you specify the project ID, data side ID, and table ID. And then this is where it gets interesting. So as I mentioned earlier, if you use the automatic DLP profiling, that it doesn't have this sampling option here, but if you use the inspection, you do, right? So you can say the sampling, you can say maximum scanner number of rows. This is something you can adjust at table level. For each table you scan, you can say, I want to scan this many rows. And again, it comes to the same thing that this is where you get the info types. You can select your info types. If you got a template created, so in this case, I've got a UK version of the sensitive data saved as a template, then you can use this to be your info type template. The rule set is the same, and then you can see there's other options in there. So once you've done all of the other configurations, you can actually decide to save the data to BigQuery or publish to PubSub when some detection happens, right? So there's lots of options in there, and then you can actually look at the report. It's got a lot more other columns, but you can see here is like you've got person name as well, but it generally gives you all of the information of the detection, similar to the automatic version of it, but it gives you a lot more granular control, especially at cost side of things. So I think I just want to spend a little bit of time talking about cost. So you rarely kind of see Google put a red warning at the top of a page of their service that warning you about the cost. So this is kind of serious stuff, because I've already heard a lot of stories that different places spending so much money on the data loss prevention service, because if you're like a little bit careless and then just try to scan a lot of different things at price in full, if you look at the prices, this is it's not per terabyte, right? It's per gigabyte. It costs $1. So if you have like a 100 terabyte table or here and there, it can easily cost you 100,000 or more than that, right? So this is why it's really important in the cost that you understand how to optimize the cost. So the automatic DLP is much cheaper out of the box, but you probably still want to get a good idea of the where how many tables you've got that has really big in size. So for example, in this particular case, you can use the for example the project dataset _tables convention to basically find out more the metadata about a specific table, a specific data set. So this you can actually look at organization level to give you a good idea of the size of those tables, and then you have a rough idea, how much this is going to cost you. If you look at the second thing, I don't know how many of you know the information schema ones, that this is where you get more details at column level. You also get table level as well in here. But the column level, let's say, one of the things kind of was struggling a little bit was on the latitude and longitude, because those are just floating point numbers, right? So it's quite difficult to just detect those even with regular expressions. But what you can do is you can look at the column name. So when you look at the column name of this table, you can check if there's anything that says latitude or longitude. So if it does say that, then what you can do is you can use different info type template. So you can have info type template for name detections or the default types. Then depending on the columns you've got in a specific table, matching certain criteria or names, then you can be a bit innovative, right? You can say, okay, if this has latitude or longitude or it has location data, then you can use a different kind of info type template with the regular expression based types to try to detect the sensitive data in a different way, right? So rather than try to use a regex for just call it latitude or just detecting a floating point numbers and then pointing to all of the tables, because then everything would be latitude and longitude. If there's kind of even money in some of these the currencies, they'll be detected as latitude and longitude as well, which isn't very useful. So I think we can be quite smart about this thing and using the information schemas and the metadata of the tables to not only save the cost on the inspection, but also give you more accurate detection results. The last thing I want to mention is once you've detected those things, those sensitive data and the info types, and a very good thing to use with those are the policy tags. So BigQuery has policy tags where you can say, these, let's say this latitude and longitude is a policy tag of, I don't know, category priority 3 sensitive data. And then once those data are tagged with the policy tags, you will need a specific IAM role to be given to the user groups or service account for those things to be able to access it. So in other words, by default, those are hidden from most services or users, which give you the extra level of protection out of the box. Okay, I hope that was useful. So yeah, that's the end of the session. Thank you very much for watching. See you next time.
Go, go, go out!